Hello and welcome to another case study of Net2Plan. Throughout this video, you will learn about the resilience simulation tool of Net2Plan and how to use it. In other videos, you have learned how to create network topologies with nodes, links, demands and routes, a static design. The resilience simulation tool simulates the network operations where failures in links and nodes randomly appear. This tool also allows testing recovery mechanisms that react to such failure events, for example rerouting the traffic if necessary. The resilience simulation tool is based on the shared risk group concept, SRG. A SRG is a set of links and/or nodes that are assumed to share a potential cause of malfunction. Thus, when a malfunction occurs, all of the elements in the SRG fail simultaneously. As an example, we have this simple topology where three different SRGs are defined. When the SRG1 fails, both of the links belonging to this SRG will fail simultaneously. If the SRG number 2 is the one which fails, then only this link will fail. And so if the SRG3 fails, only this link will be affected. First of all, open Net2Plan, then click on Tools, then Resilience Simulation. If you want more information about how to create and save network topologies, please watch the video Case Study of Line Network Design. This window is divided into three different sections. The first one, called Network Topology, is located here in this gray area. Here you will load the topology required for the resilience simulation. The nodes and links of the topology will be displayed here. In this panel called Simulation Controller, you have several controls that will control the flow of the simulation. And in the right area, several tabs allow us to see the state of the network, reviewing some statistical information, controlling the algorithms of the simulator, and viewing the simulation reports and generating reports. We will review this later. Before continuing, I will explain how the simulator works internally. Once the simulation has started, the kernel will ask for new failure and reparation events to the event generator, also called the failure reparation generator. Once those new events have been generated, they will be sent back to the kernel, and then the future event list, FEL, will be updated. We will talk about this term, future event list, when we perform the actual simulation. Then, kernel will call the event processor, or the provisioning algorithm, with the next event on the future event list. Based on this event, the provisioning algorithm will perform some actions, and those actions will be returned to the kernel to be processed. Once processed, the kernel will update the network state and collect some statistics. Then it will move to the next event on the future event list and will call again the event processor, and the cycle will repeat itself. If you click on the tab called View Current Network State, we can examine some information about the loaded topology. For example, we can review the nodes of the topology with some information like the ingress traffic or the egress traffic. We can see also the links with its capacity and the current traffic for each link, the demands and the routes and the protection segments. If you want more information about the meaning of the fields of each one of these tabs, please watch the video Case Study of Line Network Design. Also, if any SRGs have been previously defined for this topology, they will appear here. With some information like the MTTF, that is the mean time to fail for the SRGs, or the MTTR, the mean time to repair. It's important to note that the loaded topology cannot be directly modified. If you want to modify the static design of a topology, you must use the offline network design tool. We will proceed now to perform a simulation. So we will click the Execution Control tab, and before beginning the simulation, we will set some simulation parameters. For example, we can see here the default mean time to fail in hours. It's set to 8,748 hours for all the SRGs, and the default mean time to repair, also in hours, is set to 12. Another important parameter is the disable statistics. This will disable the statistics shown in the simulation report. We will see about this later, but for now we will let it in false. You can also see the refresh time. This is the time expressed in seconds in which this panel will show information about the current simulation. We will set it to 3, for example, just double clicking and inputting the new value. Also, we can set the failure model of the simulator. If the topology has some previously defined SRGs, we can select them, but for now we will use the per bidirectional link bundle model. That means that when the simulation starts, Net2Plan will create new SRGs for the topology, and it will create them following the per directional link bundle. That means it will create an SRG for each pair of bidirectional links between two nodes. For example, this will belong to an SRG, this bidirectional link to another, this to another, and so on. We can also set the total simulation events of the simulation or the total simulation time. If it's set to -1, that means the simulation will continue until it is stopped manually. If you want more information about the rest of the parameters, please view the user's guide located in the website net2plan.com. Panel, you can choose the failure reparation event generator and the provisioning algorithm. You can load a user-made algorithm or use one of the algorithms included in Net2Plan as examples. In this case, we will use the exponential SRG failure generator. You can see here a brief description about this algorithm. It generates random failures in SRGs according to a random process with an exponential distribution with mean time to fail and mean time to repair mean values. Here, we can change any input parameter just by double clicking and changing the value. We will not touch it for now. And if we click on the provisioning algorithm, again, we can load a user-made algorithm or use one of the included algorithms in Net2Plan. In this case, we will select the MPLS fast reboot. This algorithm will try to restore a root upon failure at the node immediately upstream to that failure. It has no input parameters, so we will not change any of that. And once we have set the simulation parameters and selected both algorithms, we can begin the simulation. And run will begin the simulation. Now the simulation is running, and as you can see, each 3 seconds the information in this panel is refreshed. If we click on pause, continue, it will pause the simulation. We can review here the information about the current simulation. For example, the internal time of the simulation has been 90 years, 5 months, 6 days, and 5 hours. But the CPU time simulation has been only about 15 seconds. You can see the number of process events, more than 3,000, and the number of pending events, and some statistical information. If you want more detailed control of the flow of the simulation, instead of clicking pause and continue, you can run just the simulation step by step. The step-by-step button will execute the next scheduled event and then pause the simulation. As you can see, you can just click step and it will process a new event and then post the simulation. At any time, you can click on this button, View FEL, that is the View Future Events list, where the future events of the simulation are displayed. That means that when the simulation continues running, all these events will be processed next. If you want, you can manually generate and add new events to that list. To do so, just click on Manually Generate New Event, select the SRG you want to fail. For example, we will select the number 2. We want it to fail in 15 hours, and the time to repair will be, for example, 6 hours. We click OK. Then this event has been added to the future event list. During the simulation, we can click on Simulation Report and then Update. This will update a report containing some statistical information about the current simulation. As you can see, it displays the current simulation time, the CPU time, that is the same data that is displayed in the simulation controller, but also some statistical information, for example, about the availability of the nodes of the network. Also, you can click on View in Navigator, and since the report is generated as a HTML file, it will be open on your default browser for better reviewing. Proceed now to view the current network state. By clicking here, we'll first see the shared risk groups that Net2Plan has generated for the simulation. As we can see, each risk group, shared risk group, has an identification number. The mean time to fail, that I remind you was set as a input parameter of the simulation, the mean time to repair, and the links that belong to this SRG. As you can see, now the SRG number 16 has failed, affecting the links 27 and 36, and also affecting the routes 24 routes, the ones with the numbers 137, 102, and so on. As you can see, those two links that have failed appear in red on the gray area. If we go to the links tab, we can see in red the links that have failed. And if we click on Toggle Show Hide Planning Information, we can see here the current state of the network, and in the line below the static design, so you can compare the information between the two of them. If you go, for example, to the routes tab, you can see some information about the routes that have failed. For example, the route number 11 have failed, and it has been rebooted, as you can see on the dashed blue line. You can review that the original route had a sequence of nodes of 0, 7, 8, and 12. As you can see here, 0, 7, 8, and 12. But since the link between the nodes 8 and 12 has been severed or has failed, the provisioning algorithm has rerouted traffic through the nodes 0, 7, 8, 11, 10, and 12, as seen by the dashed blue line here. Each time the simulation processes a new event, it's displayed here on the View Current Network State. Last, you can click on View Reports, and you can generate several reports using the current state of the network. You can select the appropriate report. For example, we'll use the report availability. You can set the input parameters of the report and then click on Show. The report is showed here. You can view it. And also at any time you can click on View in Navigator, and the report is a HTML file will be open on your default browser, as you can see. That's all. Thanks for watching, and please visit net2plan.com.